Hello and welcome. In this video tutorial, we're going to take a look at part 3, solving formulas for specific indicated variables from our physics math review. Remember to pause or rewind the video as necessary. Let's begin. We are going to algebraically manipulate these equations and isolate for the indicated variables that are shown after the comma. Before we start anything, let's start by recopying the equation. V squared equals V naught squared plus 2 times A times the quantity x minus x naught. Now you're trying to solve for A, which means you have to get rid of V naught squared, 2, and x minus x naught. I'm going to begin this by subtracting this over to the left-hand side. So let's subtract V naught squared from both sides, and then what we'll do is we will rewrite this. So if I rewrite this, I get V squared minus the V naught squared that I moved over to the left equals what's left over, and that's 2 times A times the quantity of x minus x naught. Again, ladies and gentlemen, I'm trying to solve for A, so I have to now get rid of 2 and x minus x naught. And I can do that since they're both multiplying themselves times 2. I can divide away the 2, and I can simultaneously divide away the quantity of x minus x naught. And notice A is now by itself. Just make sure you do this to both sides. And we're done with this one. A, the letter A, is equal to V squared minus V naught squared all over 2 times the quantity of x minus x naught. Letter B. U equals 1/2 kx squared. Again, I'm going to start by recopying this. U equals 1/2 kx squared. Now I'm trying to solve for x, which means I have to get rid of 1/2 k and the squared. Well, to get rid of the 1/2, I can multiply by the reciprocal of 1/2, which is 2. So I'm going to multiply both sides of the equation by 2, and 2 times 1/2 cancels the 1/2. Rewrite this. We get 2 times u equals k times x squared. Again, ladies and gentlemen, I'm trying to get x by itself, so I need to get rid of the k and the squared. Well, since we have k times x squared, all I have to do is divide away the k. And the k cancels. Again, rewriting this, we get 2 times u over k equals x squared. I'm trying to get rid of the squared to get x by itself. The opposite of a square is a square root. So I'm going to square root both sides, just like this. Don't worry so much about the plus and minus as we learned in math class, because sometimes in physics it doesn't make sense to have a negative root. So your teacher will help clarify when that's going to be an option. The solution that we're going to work with, though, is x is equal to the square root of 2u over k. Letter C. T sub p is equal to 2 pi times the square root of L over G. And we're solving for G, which means we have to get rid of 2 pi, the square root, and L. Well, I'm going to begin this one by squaring both sides. By doing that, that'll help me get rid of the radical. That's kind of my goal. So the left side would be t sub p squared equals, now if I square the entire right side, I have to square the 2, the pi, and the radical. So 2 squared would be 4, pi squared is pi squared. And when I square the radical, what happens is the square cancels the square root, so the L over G underneath just simply pops out. Now since we're solving for G right here, all I need to do is switch it with the other side of the equal sign, and we're done. G is equal to 4 pi squared L over T sub p squared. Letter D, F sub G equals big G M1 M2 over R squared. Now, since we're solving for R and R is in the denominator, we're going to go ahead and begin this by simply switching out with the other side. And we get R squared is equal to big G times M1 times M2 all over F sub G. Square root both sides, and we're done. R is equal to the square root of big G M1 times M2 over F sub G. Letter E, MGH equals 1/2 MV squared. Well, I'm trying to get V by itself, so in order to do that, I have to get rid of the 1/2, the M, and the squared. Like we saw in letter B, I can get rid of the 1/2 by multiplying both sides by 2, so I will begin that way. When I rewrite this, I get 2 MGH equals MV squared. Again, I'm trying to get V by itself, which means I'm now trying to get rid of M and squared. Since M is being multiplied times V squared, I can divide away the M both sides. But notice how it cancels on both sides. Rewriting it again, I get 2GH equals V squared. To get rid of the square, I'm going to take the square root of both sides. And we're done. V is equal to the square root of 2GH. Letter F. P times V equals N times R times T. I'm trying to solve for T, which means I have to get rid of N and R, which are both being multiplied times T. Therefore, I can solve this pretty easily by simply dividing away both the N and the R simultaneously. And we're done. T is equal to PV over N times R. Letter G. Q times V equals 1/2 M times little v squared. Trying to solve for little v, which means I need to get rid of 1/2 M N squared. Okay, as we saw earlier in letter B and then again in letter E, we can get rid of the 1/2 by multiplying both sides by 2. So let's begin that way. When we rewrite this, we get 2QV equals MV squared. Again, we're trying to get V by itself, So we have to get rid of m squared. Since m is being multiplied times v squared, we can divide away the m to get rid of it. Rewriting this one more time, we get 2qv over m equals little v squared. Last step, in order to get little v by itself, we're going to square root both sides. Please remember to put the square root over the whole fraction, top and bottom. And there we go. I hope you found this tutorial helpful. Remember to pause and rewind as necessary. Thank you.